Hello, everybody. My name is Debbie Brisbane, and I will be doing today's webinar on new features in RESA 3D, RESA Floor, and RESA Foundation. Thank you so much for your attention today. We've had a great response to our webinars, and we're excited today to show you kind of the new features we've been working on. Let's see here, let me talk a little bit about the programs we're going to be talking today about. We're going to be talking about RESA 3D, RESA Floor, and RESA Foundation because those are the three major programs that actually get released together. They are integrated. You can use one model in each of these programs and integrate them amongst them. So one of the things we get to do is release these all at the same time with all the major features. If you're not familiar with our release schedule, we release one major release once a year, and then oftentimes we do get two major releases in a year. So we are anticipating a release here coming up in the next few weeks, and then what we'll be doing is we'll be talking about all the programs all at once during this presentation here, but we'll also focus on the things that we'll see in each program. When we talk here, let's kind of jump forward here. One of the things that we are proud of here is we're going to be releasing everything that's going to be code compliant with the IBC 2009. So you can see from here a little screenshot on the right that the new codes that will be added are going to be the Concrete ACI 318 2008. Some smaller things that will affect you interface-wise for this. A lot of these codes got updated, didn't really do much to your interface. Concrete, you're going to see there's going to be a Lambda that was added for 2008, and that'll be in your materials spreadsheet. So you're going to look out for that. That'll be something new. The Wood NDS 2008 was added. That one really doesn't have a whole lot in the interface. You might see some wood schedules that were updated for the IBC 2009 if you're using wood shear walls. But for actual NDS 2008, you're not going to see too much interface change there. Cold form steel was added for the 2004 supplement, which is really small, really just a supplement to the 2001. 2007 did introduce a little bit more changes there. Interface-wise, you might notice some differences in your detail report. And then we also did go ahead and update the AISI database of shape materials and the SSMA database of shape materials. So those have been updated for the 2007 AISI. There's actually specifically, if you are using cold form steel, these are really different shape properties than what you were seeing there in the 2001. Not so much that they've changed the shape properties so much, but you're going to get different results there. So you want to make sure that you pay attention to whether you're using 2007 SSMA shapes or if you're using 2001. That one was kind of a tricky one. Masonry there has been added to adjust for the MSJC 2008, and that's kind of new there. Also, you've got the international codes that were updated. We put in the Canadian concrete code for 2004 and 2005, and then we updated Mexican cold form steel for 2004 and 2007. For cold form steel, that just rides right off of the American code, just like the AISI, so you'll see that will be almost identical. One of the big features we added was concrete wall design. So we've had in the program masonry shear walls and lateral walls. You can use them as gravity walls. We have wood walls in there. We had a general wall, and then now this will be brand new to RESA 3D and RESA Floor, will be concrete wall design. So what will be cool here is that we can see we're going to be able to do gravity and shear wall design with this wall feature. It looks like this wall panel editor on the right is exactly like you're going to see when you were using masonry. You can notice on the bottom here it's going to give you all the information, the materials, the density. It is based off a design rule just like it is when we use a masonry or a wood wall. So all this information is going to be similar to that. Reinforcement design based on the wall design rules. So just again, like we said here in masonry, we're going to go into the design rules and we're going to adjust all that information. We'll specifically look at that in the next couple of slides. The deflection is going to be giving you based on the FEA results. So while you're drawing walls, really what's happening is there is actually a plate model right behind the scenes. So it really is just going to be the wall is for design, but really you have a plate model that's built in and submeshed behind there for you. So you get all your deflection results based on the finite element analysis. You're going to get P delta analysis for first and second order effects there. So little P delta and big P delta for concrete walls. which is really nice there. You're going to be able to have the eye crack factors. Now these are specific for the wall panels, and you're going to find them specifically in the wall panel spreadsheet. Not going to be in the global parameters or anything like that. You're going to find it right in the wall panel spreadsheet, so you actually could change it per wall if you had a different crack factor. And then we have a comprehensive detail report that we're going to be able to look at specifically when we get into the program. So what I'd like to do is walk through these slides first, and then we'll jump into the program. Okay, so the next one here, let's talk a little bit about the concrete wall design specifically for the design rules. So here we see that the program is going to be giving us a design rule for concrete wall rebar and cover. What we're looking at here is actually going to be our cover information. We can tell the program to use either outer bars for the vertical orientation, so we're going to tell the program to put your vertical bars on the outside, or we can tell the program to use horizontal bars on the outside. Now that affects the way your D is measured from the vertical bars. So you can see in my picture here, it's a little hard to see, but you have a little D in there, and it's going to be measured from whether it's from the outside or from the inside, and that's going to make a difference in your calculation. You can also tell the program just to use centered location or each face. So what we're looking at here is on each face reinforcement, but we could have told the program to be using bars centered, which will run the bars right directly through the middle of the wall. The next thing you have control over is whether you're going to be doing any different cover from the inside or the outside of the wall. So you can tell the program here, and you see this is internal cover versus external cover, and you can tell it whether you're going to be having 1-inch cover versus 3-inch cover on the interior or the exterior. You can also tell the program there to do an edge cover. So what you've got here is you're going to see this little 2-inch distance from the edge. You can tell it tell it 2 inches right there on the edge. The last little piece is this dimension up here, and that one's just because what we're doing is we're centering those bars. So what we have here is a little bit of extra. So we're using, in this example, 3.62 inches extra on the side because the interior bars are all going to be all going to be spaced evenly, and that extra little piece is spaced out here. So it's just an important note to make there when we look at the detail report. Concrete walls here are also going to be color-coded based on the rendering view. So what's happening is when we just talked about here, we have the ability to do interior and exterior. Well, it's important to know that you can see that, which is the interior versus which is the exterior. It could be kind of tough if you didn't know that. So one of the nice parts is that we've got it color-coded. So the exterior is a dark gray color. The interior is a light gray color. So you're going to use a negative Z there. And this Z, when I have that little Z in that positive Z, what that's indicating is your local axis. So you can indicate, actually, if we could turn the local axis on, we could say, okay, that would be the positive direction of the local axis versus the negative direction of the local axis. One of the tools that we gave you here now also is that if you make a mistake and you, by accident, which happens to me a ton, is I draw the walls in the wrong direction, what I do is I just can use this flip axis tool. And it's directly under my Draw New Walls. You'll see a new tab called Modify Wall Panels. And right down at the bottom, you can say Local Axis Out of Plane Flip. So what you can do is you can flip those axes for yourself. Okay, that's a really good tool there. And then the next piece here, we'll go back into concrete walls, and we'll actually, when we jump into a model, the next really great tool we added into here is seismic detailing and design provisions. Now this is a big actual feature. It covers a lot of different codes here. So we cover the AISC specification for structural steel, which is just this AISC 36005, and that's the spec. When we read in the code here, it refers to the spec. That's what we're talking about with the 36005, and that's your standard steel code. Okay, but it also adds in the AISC specifications for seismic provisions, and those are covered by two different specs, 34105 and 35805. If you look in that book, there's a lot of different information that's covered in this. I'm going to kind of cover on some of it, but this one is really detailed, and we're going to actually do a whole webinar at the end of the month on specific seismic detailing because it's going to be a lot of information. So let's see here. One of the things we do, first let's just talk about the fundamentals, is we're basing these provisions on a seismic design rule that you can set up. Those seismic design rules get applied to any of the members that you want in your seismic lateral system. So a braced frame or a moment frame, you can assign the seismic design rule to, and we'll look specifically at that design rule. You're going to be basing it on the member type. So it's going to be you're going to be telling the program a beam, column, or brace. Now this is a departure from a lot of the way people model right now. So a lot of times in Reset3D, people just ignore what they're doing, whether they're drawing in a beam, a column, or brace. And this is something you want to make sure when you draw your members that you tell the program what kind of member it is, a beam, a column, or a brace. And when I say brace, I mean V-brace typically. That'll be your vertical brace. But we'll see that too in the model. This is also going to be applying to our earthquake loads. So when you use our load combination generator, it's going to help you develop these earthquake loads. Also with overstrength, this is something that did get added in the last version of the program, but I'm not sure if everybody knows and has been using it. So we will review that. If your overstrength is required, we have, you're going to have basically overstrength possibly for maybe your beams, and maybe not your columns. Reverse that. However, it's set up in the code that you need it for one, not the other. You can adjust that. And what you will specifically look at is you're going to need to make sure you use your EL or your ELX, things like that, where you're going to actually use the earthquake load in your load combination. And the load combination generator is going to actually automate that for you. Results in the detail reports and in the spreadsheet. So what we're going to see is where all of the output we're going to get is going to be listed in each member in the detail report and then summarized in the spreadsheets for us. Okay. So we'll look a little bit closer at seismic detailing. First of all, what are the things we're doing with seismic detailing? It's kind of a vague topic, and so this kind of goes in a little bit farther. We'll talk about a lot of the little things that we're going to be calculating for you. We're going to be calculating the moment demand based on the probable plastic moment, the MPR. We'll see that we're also going to be calculating the panel zone shear requirements. You're going to get a whole big area on what the panel zone requirements are for shear. As well here, we're going to do a calculation of the required shear demand for moment connections. We're also going to be going through here. So this is actually, looks like my picture's a little off here, but what we're going to be doing here is we're going to be doing the compact sections. We're going to be giving you, whether it be a seismic non-compact, looks like that, or compact for seismically. You can find that information right off of your 358, actually, excuse me, 341 is where you're going to find that. And that's going to be in the tables. And what it's labeled in tables is sections that satisfy local buckling requirements. Right there will tell you whether it's seismic or non-seismic compact, and what we can do, the program will check it right there for you too. We're also going to do clean column checks for you, so we're going to tell you whether you need stiffeners in that or you need continuity plates, and that'll be based on your columns. We're going to give you some strong column, weak beam checks for you. So it's going to be, the program will actually know what frames into it, what the beam frames into the column, and it's going to check that information for you. We're going to do braced slenderness checks. So if you have a braced frame, we're going to do the slenderness checks for you. The calculation of the unbalanced forces for the braces, that's an interesting one. I'm going to show you a little bit more about how we're doing that. But that's going to be calculated there for the brace and then reported on the brace and also reported on the beam that it applies to. And then we're going to do some checks for the AIC 358, limits for pre-fault qualification and testing there. So you're going to get a lot of miscellaneous checks during your check, during your analysis, and it'll report to you. And most of the information when I have this all listed out, this is just some of the long list, and it gets a lot more detailed as you get more involved in whether you're using a special moment frame or an intermediate moment frame. But I kind of wanted to give you a brief summary of some of the things we're doing. But what you tell the program specifically is in that seismic design rule. You're going to be able to go into the seismic design rule, and this is a default that will be set up for you. So what's nice is you won't have to set up your defaults, but you will want to know what things are happening in here. So what you'll first notice is that it's broken up in tabs as column, beam, and brace. So you'll be able to open a seismic design rule up, and you'll have the column, beam, and brace broken down. And the first thing you've got here under columns is your frame ductility. And the frame ductility, you're going to tell the program whether you want high, moderate, or minimal. So what we can see is for a special moment frame, it's high ductility as the default right here. As an intermediate moment frame, it's a moderate. As an ordinary moment frame, it's a minimal. Okay, so those are going to be the setup, basically, kind of as you're following there. And then the next column, you tell the program whether you need overstrength required. So as I mentioned, a column is going to have overstrength required for a special moment frame, and also for the beam tab here, we have special moment frame. We have that checked for the overstrength. But for the intermediate moment frame and the ordinary moment frame, OMF and IMF, those are not checked on for overstrength. So you can actually get that. We're going to be using the overstrength load combinations for some of these things versus for other things. So load combinations just got a whole heck of a lot more complicated, but hopefully through these quick check boxes, it makes it so easy for you to be able to just check on and check off when you want it to apply. The other thing that we see here in the beam spreadsheet is a Z factor, and that's going to be the ratio between the Z values for the reduced and the unreduced beam sections. So for RBS, for reduced beam section type of connection, you're going to have this factor that you're going to apply there. It's going to be, you're going to calculate that based on how much you're actually taking out of that beam in that dog bone area. The hinge location is another thing you can tell the program here if you're any of your moment frames, and that's going to be your hinge location measured from the face of the column to the hinge. Okay, so those are the columns really that you need. The brace is just going to ask you for if you want to be applying the KL over R, the special KL over R for that. So that's really all you need to do for seismic design rules to set it up. The rest of the here, and it looks like one more, sorry, the last column is the moment connections and how you're going to be doing the moment connections. And we're going to see that in the next couple slides about telling the program what you're going to be using. But that's really all you need to set up, and what's nice is these defaults are there for you to get started. So for seismic detailing here, I'm going to actually jump ahead really fast. The moment frame types, I just want to show you this before we jump into the results. The moment frame plate types here do show you that we can do bolted flange plates, and that allows you to do here what this picture is showing here as a bolted flange plate at BFP. The program will use a lot of these short acronyms, but they are also in your help file if you get confused about what you're looking at. You have bolted flange plates available. You have the reduced beam section, and this is going to be used for the special moment frame or the intermediate moment frame. And what I mentioned there, we're asking for that hinge location for the RBS. So you've got that distance right there. The next ones you can do is the moment frame types using the bolted unstiffened extended end plate, or the BUEEP. Okay, that one is a picture is just showing you here, so this one's just not stiffened. The next one you can do is just a stiffened version of that, a bolted stiffened extended end plate, and you've got that stiffened right there. The next one you can do is a welded unreinforced flange welded web, so WOOF, W, that's kind of that picture right here. So you've got all those different options. And the last one is going to be your actually be your braced frame. I don't have the next slide is going to show you a picture of the braced frame here, and I'll show you a quick picture of what we would talk about with a braced frame. The braced frames actually we can do a braced frame like this. We can do inverted. We can do any sorts of braced frames here as long as it's a concentrically braced frame. What we've got here is a picture. What I wanted to show you specifically for the braced frame is that it's important that you note that you can get your unbalanced forces. And what our unbalanced force here is going to be showing us is that we've got braces. You apply these braces, you've got forces in the tension direction and in the compression when we apply the load to it. You see that a free body diagram of the tension versus the compression and where it connects into the member. If you see what happens typically with a brace frame, you're going to have a compression brace, and the code is going to tell us that we can use up to the tension value right here, but we need to reduce the compression value, and as that buckles. So we're only going to be using 30% of the compression strength in this one, in this brace right here. And so what happens in the model is that you get an unbalanced force in the beam. So the beam is going to experience this unbalanced force. And so what RISA is going to give you here in this detail report is going to give you the forces of that component on a detail report. It gives you the forces of a component. So this unbalanced force is broken into two different components, vertical and horizontal force that's going to be applied to the beam there. And we're going to give you that force there in the actual brace report, and we're going to also see it in the beam report. One of the things I did want to quickly, show you, I misordered my slides, but I do want to show you a little bit about what the color display is going to be able to give us. So seismic detailing here is going to be able to show us the color coding and the display of the design rule on the actual member, which is cool. You've got we can see here we're using ordinary concentric braced frame, specially concentrically braced frame, all listed on there. If by chance we made a mistake and we were mixing things up, we would see that color coded. The other thing it's going to do is give us column stiffness checks right on the color coding. So I just like to show you how that looks in the legend. It shows us whether it's going to need web doublers, whether you're going to need continuity plates, or in green, a clean column check, basically. So the whole model we can color code, and if everything turns out green, then we get, meaning basically we have clean columns all over our model, which is great. So that's an easy way to check it, and everything in gray doesn't apply, okay? So we can see that in the model. I'll show you that once we actually run the model too. Let's take a look, keep going. Sorry about my misordering. And let's see here. So the next piece I want to jump into is some of the little things we've got in RESET Foundation that and we'll be able to see this too, is what we added some overturning for the mat slabs as well as the sliding checks for the mat slabs. So when you're in your RESET Foundation, we've added safety factors tab right at the bottom, and you'll see an overturning safety factors and a sliding safety factors spreadsheet here. And that's going to give you all the different information. So when you're doing a combined footing, you'll get everything you would have gotten if you were just doing a single footing for the overturning and the sliding checks. We also added a new quad measure for the FEA analysis. So that's going to make everything much faster for your slab design and more accurate. The quad measure is something that went in, when we talk about quad measure, we're really just talking about the plate design there and the plate analysis. And that's what is happening in the wood walls and the concrete walls that we have, as well as the masonry walls. And so we were able to put that right into RESET Foundation, so you get a speedy result compared to what we had in the older versions. The other thing is we've got a pile cap export. So we now can be able to export all of this DXF right here directly for the pile caps as well. We have a lot of different DXF export options, but pile caps was one of the last things to get in there. So additional checks that we've got in the program too is that we've added several little things here that I'd like to point out. We have single angle bending checks. That's a big one that folks have been asking for a long time, be able to actually apply bending to a single angle. It wasn't so typical when RESA 3D came out years and years ago, but it sounds like lots of folks are trying to actually use their single angles for bending. So we added that directly into the program. I showed you a little bit about that wall local axis flip. So that was an easy thing to see, but we can also see that in the program. We added P-delta for walls. So concrete was one of the things that required that, but we were able to add that directly in also for masonry and general walls. You have the P-delta analysis. One of the things you're going to see is that we had some enhancements to the masonry walls. So if you are familiar with using masonry walls, there are just a couple of enhancements and reorganizations, and I just wanted to point out so you don't get lost that some of the things like self-weight went directly right into the material spreadsheet, as well as you're now going to find your steel FY in the material spreadsheet. Okay. One of the things here I want to do is jump right into the RESA floor and see a model in action. Specifically, we're going to jump right into this model. It's just a 3-story model I built. It's just got some moment frames and some concrete walls, but in particular, I just wanted to show you a couple of the aspects in this model that we added here as differences. So like I mentioned, you've got the codes that were updated directly from what we've got here. So you've got the 2007 AISI, and I'm running here some wood, 2005 and 2008 wood. The seismic tab has really been the same in RESA Floor since you've been doing a lot of this in RESA Floor forever, but you will see that you have the omega factors in here that you've been added, so you've got, and the row is added in here. You also, let's see here, let's take a look at our concrete walls. So if I just double click on a concrete wall, this does have reinforcement listed on it. You can toggle your reinforcement on and off by just clicking this button on the left. But like I mentioned, it's going to be based on my design rule information. One of the things I didn't mention in my slide that's really important is that in your, you can control this reinforcement, the design of that reinforcement, directly in the wall design rules. The concrete wall rebar here, that first tab, gives us the ability to control the vertical bar spacing and the maximum and minimum spacing there. You've got the size and the maximum spacing. You've got the vertical increments. That's telling the program how often to increment that when it doesn't work for design. So we start at 4 inches, we go up to 6 for going for incrementing by 2, then we go to 8, and so on until we get to the maximum vertical spacing. You also have, I'm not going to clear my results so we can jump into the next program real quick. You also can control your horizontal bar spacing, okay, and you can see that you can control all of that right there from there. Another thing to note is that we did break up the design rules. So you're looking at something called member design rules now, and separately you're looking at wall design rules. So I just don't want you to get lost if you're familiar with just that design rule tab on the data entry. We broke it up into 2 different items. So you've got that listed out for you. What we can do is we can also look at the detail report here in ResetFloor and see what we've got available now. This is only for gravity loads, but we look at the ACI 31808, and what we're seeing here is an echo of all the information we put in. We told it number 6 bars for vertical, number 4 bars for horizontal. We told the program here that we were going to be using the materials that we had in here. But we scroll down and we can see there is one region and it's being controlled here by load combination 2, and this is the detailed picture of number 4 is at 18 and number 6 is at 18 on center each face. And then I can also look at the region report. Okay, again, this is only really looking at the gravity loads. We haven't gotten into lateral yet. So what we see here is just the gravity information, and we see a nice detail report with a cross-sectional detailing at the bottom. So we'll look at this a little bit farther in 3D because it'll be a little bit more informative. So what I want to do is jump right into Reset 3D using my director button at the top right. I move from this model into Reset 3D. Now in Reset 3D, I tell the program the wind loading that I'm going to be applying onto the model here. I'm just going to say OK. And the seismic loading, I already have placed in some numbers in here, but you've got your R factors in place here. You've got your SD1, SDS, and S1. I put in some of the ones for our region here, so kind of high California numbers. And then if you scroll in here, you can see the seismic generation input here. We scrolled down just a bit. We've got all the seismic forces that we're going to be putting in. Okay, and if I say OK, I jump right into my global parameters. First thing off the bat, if you are a straight Reset 3D user, you'll notice that there is a seismic tab. This is brand new. You're getting a seismic tab right inside of Reset 3D, and you're going to be using your omega values right there. You're going to see your rho values right there. The rest of these values are going to be used for your seismic load generation. If you're not using seismic load generation and you're applying your own seismic loads, then you don't really, these won't apply to you. But it can't hurt if you want to use our seismic load generator. You just go into Insert, and then you can use seismic loads. Now, the only caveat there is you do need a diaphragm if you're going to be using the seismic load generation. But that is an important piece. You need to make sure you address your omegas in here if you're going to do the overstrength when we're talking about the seismic detailing. So you'll notice only the lateral portions came across, so only my braced frames, I came across. I got my moment frames. One of the things that we've got here, let's take a look. We're going to look at the members, and we're going to look at them color-coded. I mentioned that you can show the seismic rules, and you can also label the seismic rules. So that's a good way for us to see what the heck I did in my model. It's got some colors, and it now shows us seismic rules here. So it's telling me in the pinkish color, I have ordinary concentrically braced frame. In the bluish, I have a specially concentrically braced frame. I've got some ordinary and some special braced frames here with RBS, all of that in place. So this really helps, see what we're looking at in the model. The next thing we can do is we can just take a quick look at my load combinations that I was using. So I already set up my load combinations, but I do want to show you how easy that was to do. So when you have all of your dead load and your live load laid out, that's pretty easy. But these earthquake loads, especially when we start using this overstrength omega, it's going to start to become pretty fast, growing pretty fast here. We only have 15 listed for me, but it can go a lot larger, especially if you're using any snow loads, things like that. So with the load combination generator, if you haven't seen this yet, basically you're going to be applying in your IBC 2009. You can use strength. I have strength laid out here right now, but ASD, and you can tell it to use notional loads for the gravity loads in here. I'm going to jump to the seismic tab, and you can turn in, if you're going to be using the load combination, the seismic loads that are generated by RESA 3D, then you'll want to use the X and Z or the X and Z with eccentric, those two options. And then you're going to be telling the program here, do you want to apply the rho, do you want to use the EV, do you want to use non-orthogonal? And this is going to be multiplying lots and lots of loads. And then also, which loads do you want to use for overstrength? So again, if you're using the load combination, the load generator, you're going to want to use the X and Z with eccentric. And then you'll be able to see that laid out there for you. I'm not going to create as many as that because I want to show you a little bit more information without having to rerun the model. But this is where you're going to do it, and you would just say generate, and it would generate just tons and tons of load combinations for you. You also can kind of weed things out. I let everything, all of these different combinations be run, but you'd probably want to sort of go through here and say, okay, I didn't really use any live load special, so this might be redundant if I'm doing things like that. Or go ahead and use them all. I'm just going to create a little bit of a larger model for you. Okay, so I'm going to close that for a second here. And one of the things, let's take a look. This actually, we have results already present, so we can jump into some of our results and take a look at what we've got. Seismic detailing, first thing off the bat, we've got a new tab here, so it's called Seismic Detailing. If you open that up, it breaks things down based on columns, beams, braces. The columns is the first tab here, and it does break it down and gives us an idea of the seismic design rule that was used. Tells us the ductility. Okay, so those are things that we put on the input side. It gives us the unity check max, what load combination was used for that unity check. What's an important new change here is that you'll notice that 13 is there, but it's got a star next to it, and that star is indicating that that was an overstrength combination. So what was important for us to let you know is that, okay, load combination 2 was actually a gravity combination, so not quite controlling us, but then if maybe this one right here, this is actually being controlled by an overstrength combination. As we scroll down, looks like that might be the only one on this comment for my model there being controlled by that. But that's an important note. You'll see a star in anything that's being controlled by overstrength. And then you've also got slenderness checks, whether they pass or fail. Okay, so we're going to maybe go into the detail report to investigate farther about what happened, and you can click on the detail report right there. But I'm going to keep going until we jump in there. The panel zone checks is going to be not applicable for certain things. Okay, so for a brace frame, I don't have panel zone checks, but then when I get here, I have a special moment frame. It's going to be failing that panel zone check, so I might want to go in and investigate that. It's going to give me the equation that governed for that. Whether a continuity plate was required is listed there for me. I'm going to close some of these down a little bit. We also can see we have strong column, weak beam listed there, and then whether it passed or failed or whether it just didn't apply. Okay, and so, and then you've got the miscellaneous checks. And there's a lot of different miscellaneous checks, and you'll want to be able to go into those specifically in the actual detail report when it says fail to see what was wrong with that. The same thing, you can go here. Let's see, I'm going to scroll over to the next page here. Sorry, this is a smaller screen than I usually use, so it's a little harder to navigate. But the beams have similar information. It's going to tell us information again, whether it's a seismic, what type of frame it was used, whether the ductility was, and then what passed and failed. Required shear is listed there, required moment. You've got all that listed there. You've got strong column, weak beam. And then you have some span to depth ratios that are listed, and then the miscellaneous checks. And then the braces we also have here, required tension, we've got required compression, the unbraced vertical force that you might need to apply to your beam. You've got unbalanced beam there, which beam, excuse me, that you might need to apply this unbalanced check there, and then the miscellaneous checks, or whether they pass or fail. So this is kind of just a nice summary. It's a lot of information, but what is, I think, more important for you is probably when you go and say, okay, what's going on in that one? Why is it failing, and why do I need a continuity plate? So you can click on one of these members and then just go straight to the detail report. So the detail report is going to give you the full story. First of all, it's going to be just your standard detail report. You can notice you've got all of the axial, the tension, the moments, all that listed out there for you. Pretty standard stuff. The first whole area is going to be the AIC 36005 check, so this is your standard field check. But then way below that, you get a whole bunch of information. First thing off the bat, it's important to note, I ran a batch solution. So when I run a batch solution, I can look at a detail report. It does envelope that for me. Okay, so when I'm using a lot of terms here, batch solution is going to be running through each load combination, solving and saving each results for each load combination. The envelope seismic detailing results are actually going to take every load combination that was run and find the worst cases for me, because that's what I'm going to be important here. I don't want to look through all the different load combinations to understand what's happening. So the envelope seismic detail results is going to be helpful because it's going to actually do the worst case for me. So we're looking at a column, and we're looking at a specialty moment frame with the reduced beam section here listed out. Was this needed to be designed for overstrength? And yes, it was. We've got frame ductility as high. This looks like I am using a seismic non-compact there for my bending flange and compression flange. I have an L/R ratio. Looks like I might need some bracing here, so I have looks like I'm higher than the 60. The panel zone looks like it's failing. Okay, I've got web reinforcement required. That tells me which beams we're framing in and what their demand was versus what their capacity, and then the magic number here is the unity check. Under UC, it tells me that it was higher than 1.0, which is why it's going in red. So that means that I might either want to address this by sizing this up or working on the connection, okay? The next piece here gives me the continuity plate summary, and it tells me I need a flange stiffener required, okay? And then again, it gives me the demand versus the capacity. It gives me the controlling equation for these different pieces here, flange, web, okay, and we'll go through each one. And then it gives you the unity check there in red. So it looks like I have a lot of failures. I really didn't size these things up. I sized them for beam sizes, but I didn't really worry about a lot of the seismic stuff. So I would have to then say, how do I want to address this, and then rerun it. The column beam moment ratio, it looks like it's passing. Okay, so it's taking the sum of the moments there and giving me a ratio, and it is passing. I've got the column flange bracing force and gives me the demand there. Okay, so this would be what you want to use for your strong column weak beam there, and we have, looks like we're under 2.0, so we're in a good shape. Okay, so that's going to be for my column. Let's take a quick look at a beam. In particular, another way to just go right into it is just click on your detail report and click on a beam. And I want to show you a brace frame beam. Again, it's just going to give me information just like we saw. These are a little staggered because I'm looking off SAGE results, so they're a little funny looking, but should be very similar to what you're used to seeing in a detail report. But here in particular, this beam, what it's giving me is just whether it's seismically compact here or not. It's giving me, actually just compact, excuse me. This is a minimal frame ductility, so I don't have a lot of requirements for this beam. But what it does give me is information based on that unbalanced force on the beam. So if you remember when we looked at that unbalanced force, we were seeing the braces coming in, two forces, one's in tension and one's in compression. And we've got 30% here is going to give me the low value here. This is going to be based on this equation. And what we get is a overall force on the beam, and that force is going to give you as a horizontal component and a vertical component. Okay, so if I wanted to go ahead and on this beam account for this, I would go ahead and put the 38 kips directly as a point load down on that beam to account for that. The horizontal one component is something that probably people don't put into the beam, but the vertical component might be something I want to go ahead and put a 38 kips directly on that beam as a point load. Okay, and that was this beam right back here. We can look at a brace. If I click on, let's click on that brace actually that was contributing. That might be a helpful thing to see. That brace that was coming in here is going to give us the K/R. So there's a special criteria based on the 360 that we want K/R to be 200 for this year. So we've got that under there, and that's going to be okay and checking out. We've got right here we're going to see the required connection axial strength and the two compression and tension values there versus the actual. And then we now see that below the same information we just saw, that 38 kips that's applying to that beam. And the beam here is going to be the one I just checked out. Okay, so you have all that information on the beam for the brace frame. For moment frame here, we can look at a moment frame beam. That might be something that's a little bit more telling here. We've got, this is going to be for this especially moment frame. It is seismically non-compact. The beam to column, the column to beam moment ratio did pass, and the span to depth ratio did pass. It gives us all the bracing information for the beam bracing information, and then it also here gives us the required connection shear strength, and it looks like our demand here, and we've got our demand listed here for the required connection moment strength. So we're going to look at our VG, which is our shear for gravity versus our probable shear, and we've got the overstrength there right there. Okay, so all of this listed out, each one for each beam, each column that you design there, and you go ahead and tell the program that you're using that seismic information. So you've got lots of ways to use this, but in either as spreadsheet results, in a detail report, but it's going to give you all the different pieces. And then let's see here. So let's also look at our concrete wall. So if I take a look at this concrete wall, I'm going to zoom out here and look at this a little bit farther. This is really going to be where you're going to really work with your lateral walls. You can use in-plane and out-of-plane. This is just like we saw in RESA floor. The in-plane, this is just our overall number 4 is at 18, number 6 is at 18, each face and each direction there. It shows us, it now gives us the different load combinations that are using for in-plane, out-of-plane. Okay, we get a lot more information listed there. We also can see in the region report, and this gives us what's happening per region. Okay, so the geometry and the criteria and the materials are all coming right off of our design rule. We told the program what bars we wanted to use. We told the program what material to be using. And then as we scroll down, here we have an I-cracked factor here. As we scroll down, we see what the bending results are and the shear results, the envelope. So this is telling us the minimums and maximums for the shear, the axial shear and moment. And if I scroll down, it gives me the deflection details here, listed out what was the deflection. We have the area steel provided. And then below this here, we get the in-plane wall interaction diagram. Okay, so we're now seeing the moment versus the axial there, and then we now also get the detail report, or cross-sectional detailing of what this actually looks like in plane. Out of plane is going to be just a click on the top of the screen. You switch from in plane to out of plane. And then we see below that you get 318 all listed out, okay, but it's going to give us a little bit more here of races on the axial and the bending. We're now talking about the positive and the negative of the local Z direction because we're doing 2 different types of reinforcement out of plane on each face. Remember we talked about little negative Z and positive Z. That's all in relation to the fact that you're using interior face versus exterior face reinforcement. You've got your shear details listed here in your deflection, and as I scroll down below that, I now get an interior and exterior interaction diagram. It gives me the slender bending results listed here, and as I scroll down to the bottom, I'm looking at another picture of that cross-sectional detailing. Okay, so you've got a lot of information. One of the pieces I did mention, hey, I've got a lot now even going in the detail report about that positive and negative Z direction. One of the things I did do, if you'll notice on my drawing, I kind of screwed up here. It looks like I did 2 different directions. I have a dark gray on this panel. I have a light gray on that one. So what's happening is I'm looking at a whole row of walls, and they're actually going to be in and out of plane, sort of real confusing results. So I can just flip that by just going to my wall panel flip button. If I just click on that wall panel, that's the same dialog that I'd be using to draw a new wall. But if I go to the Modify Wall panels, the second tab, I can just say Use this out of plane flip. And I can just apply that by clicking and just apply, and what you'll see is that gray flips to the other side and that gray flips to the other side. So now it's just more regular. I also did something a little odd. I drew walls separately. I drew 3 panels, but in RESA floor that was just sort of the way I drew it. I could have drawn one whole large wall and I would have gotten results based on that. Okay, I'm just going to solve this here as an envelope solution. We're going to run through and see that. But what you're basically doing here in Reset in Reset 3D is just getting separate results for this, and we'll see those results in a spreadsheet here right a second. It's running through all my load combinations. So now when we're examining this concrete wall, I probably didn't need to run all my over strengths, but that's okay. We'll run through it anyway. And it's going through all the different combinations and P deltas. I did have P delta turned on for everything, so it is helping me there. And what we'll see, let me close that out. And I'm going to take a quick gander at what we've got going on in the results here. So what we'll see in the results toolbar, I've got concrete reinforcing spreadsheet, and it starts with our beams, goes to my columns, and I'm going to go to the walls in particular and take a look at the wall results. And I've got horizontal bars listed out, I've got vertical bars listed out, and the thickness of each wall. I also do have wall design results here. This gives me a little bit more of the design information. We have it concrete in plane and concrete out of plane. Concrete in plane gives us the maximum unity check shear, and we see the PN and the MN fee, VN fee. I've got all that listed out. I also have the concrete out of plane listed out for me here too. Okay. So lots and lots of results for concrete walls. We kind of hit a lot of everything in Reset 3D and Reset Floor. I'm just going to quickly jump over to Reset Foundation for just to tally up all the different pieces we've got in here. If we go using the Director button, we go to Reset Foundation. All of the information that came across goes in from Reset 3D to Reset Foundation. And I'm going to solve this model right here, and it's just going to go through a couple of different load combinations here, solving all the different stuff we did. One of the things, if you haven't seen Reset Foundation in a while, what you'll notice is we're looking at a lot of different things. We've got footings, we've got pile caps, we've got combined footings, slabs. I didn't do any grade beams in this model, but you could have grade beams. Combined footings also, so like I mentioned, a combined footing, basically you can put a slab down, you can put pedestals on top of that, which is what we did here. In this pink region, I put pedestals on top. I have a slab below that, and then I have, I'm going to be able to get my overturning checks on that. I'm going to be able to check my, all of my different information, just like I would on an actual footing, but this is going to be a combined footing. So it just takes a little bit of time. Reset Foundation does have the added, it's doing all the different load combinations here, but it's also submeshing these plates, and then we are getting design on top of that. So a lot of times you'll see really the design is what's taking the time when it goes through the solution. But it is going all the way through here, and let's see what we get. So if I look in isometric view, I can see I've got some pile caps on top of here. But the one thing that I want to pay attention to is the new items that we got in here, which was we are doing a safety factors here. We are looking right at the safety factors. On the last tab, I have slabs. I can see that I have moments and the X direction and the Z direction. In the sliding, I have overturning checks. I have sliding checks, and both of those there are listed per slab. And they give you the actual applied lateral forces and apply in those directions, and then versus the resisting, and then it gives you a nice ratio there for you at the end there, so you have the safety factor ratio there. So you've got that listed out. You're also going to be able to export that based on the pile cap details listed right on there. So you already had a lot of different export options: foundation plot plan, slab reinforcement, footing details, pedestals, and then now you're finally be able to do your pile cap details. So really everything in this model can be sent in and out as a DXF, sent out as a DXF. Okay. So you've got a lot of stuff going on in here. Let's just jump back quickly at here. And basically at this point, just leave it open to questions. Hopefully this was just a little piquing of your interest of what we've got coming out. There's a lot of little things along the way, obviously, and a lot of little small, teeny little enhancements that I didn't get to today, but I wanted to show you some of the big features, and we are planning on that, releasing that in another few weeks here, so look out out for it. It will be, if you are under maintenance, you'll automatically get that. If you are interested in trying to get the new version, definitely let us know. You can contact us at info@resettech.com, or you can take a look on our website. We will be posting this video on the website and also the Q&As. Unfortunately, as Matt mentioned, that the models won't do you any good until it is released. So we will do that. We'll give you this model once the program is released. And we'll be online here for a little bit, but let me pass this back over to Matt. Thank you so much for your attention today.